Hi, and welcome to the session Python for Geographers. I am Manushi Majumdar, the Data Science Product Engineer on the ArcGIS Hub team. I also develop ArcGIS Hub's Python API that helps you automate your workflows, your hub workflows in Python, and do a lot more with it. Let's get started with the session. The goals of this session are threefold. We'll first see how to read and understand Python scripts. We'll also look at the essentials needed to set up a scripting environment in Python on your machine. And we'll also look at ways to teach ourselves Python moving forward after this session. The agenda for this session is as follows. We'll first look at the bare basics needed to get started, such as installing Python and verifying it has installed successfully and other must-knows. We'll then demystify Python to understand all the moving pieces that go into writing Python scripts. We'll take a look at Python open source packages popular for data analysis, data visualization, data science, machine learning, and even geospatial analysis workflows. We'll look at an example on using the ArcGIS API for Python to perform GIS and data analysis. And we'll conclude with learning resources. It's an extensive list that meets you where you are at in order to help you learn and grow your knowledge of Python. So what really is Python? It's an object-oriented free scripting language. It's commonly used to automate tasks, and it supports user-friendly data structures, which makes its syntax extremely easy to learn, understand, and adopt. It's easy to use, which also makes it ideal as a language for prototype development. That is, you have an idea and you'd like to test it out to see how feasible it is. Python's a great choice for that, for quick prototype development and checking its feasibility. There are several benefits of scripting in Python. I've laid out a few here. Scalability is a big benefit. It can be used for both small, simple scripts to large, complex projects and everything in between. You do it by importing modules that you write in other programs or other projects, thus scaling it and expanding it. Another great strength of Python is the integrated packages that come along with a Python distribution. And these, you get an access to a large, wide-ranging suite of packages, which basically are just modules or libraries written by other people that can be imported and used by you in your workflow, thus enhancing your work in the process and not having to reinvent the wheel. Also, the functionality supported by these integrated packages is wide-ranged, from like database to networking, web scraping, web framework, even scientific computation, analytics, machine learning, deep learning. The sky is the limit. And the third great benefit of working with Python is it's built by this dedicated community of open source developers. So basically, it's a language built by developers for developers that makes it very easy to use. Also, it's very easy to distribute even for commercial purposes that makes it a language of popular choice for building products. So, how do I really get Python? There are several distributions and package managers for getting Python, such as pip and virtual environment and Anaconda. My personal favorite is Anaconda because it's great for your data science and machine learning workflows. Let's take a look at getting Python through the Anaconda website. As we see here, it's the world's most popular Python or R data science platform. It comes with all the packages that you need and more to support your workflows. Getting Python through Anaconda is extremely simple. You first download a graphic installer for getting Python. You pick your particular operating system and then either select the older or newer version of Python and download the installer. I'd recommend working with the newer installation of Python, the newer version, because most of the newer machine learning and deep learning packages developed are developed for the newer version of Python. So once you've successfully gotten the installer, downloaded the installer, you then install Python using it. To install Python, you select the particular sequence of steps for your operating systems. Since I'm using Windows, let's take a look at these set of steps. As you see, they've laid out the instructions to navigate that particular graphical installer very clearly, and following through and making the choices for your environment will easily help you install Python. And once you've installed it, you can verify your installation by checking for the presence of Anaconda Navigator and Anaconda Prompt on your machine. Since I've already installed it, I'm going to look for Anaconda Prompt there. As I see, Anaconda Prompt is installed on my machine already. And to verify the successful installation of Python, I need to execute the conda list command. Once I execute it, it's supposed to return a list of installed packages and their versions. So testing it, there I see an exhaustive list of packages that come pre-baked with the Anaconda install, and this also gives me the package versions which are of the packages which are in sync with each other, thus helping me set up an environment ready for scripting. Another thing I'd like to draw your attention to is virtual environments. Virtual environments can be thought of as a great technique for creating isolated working copies of Python so that you can maintain specific versions of packages without affecting other projects that need or use other packages which are unrelated to the packages you are working on and could potentially conflict with it. Let me give you a classic example. Let's say you're working on two particular projects. One is a web development based project and another is a machine learning based project. The web learning based project would require a certain set of packages which the other would not, and vice versa. So creating separate environments helps you create separate copies of Python to cater the needs to that project so that you can install other packages that are specific only to your particular project, thus avoiding any kind of conflict. This set of instructions is only for a conda distribution. So in case you have Python through pip or virtual environment, you may have to refer to another set of instructions for creating environments. But for those who have an Anaconda distribution of Python, you first check whether conda is installed and its version. Having done that, creating a virtual environment is very easy. It's a one command that you execute that's going to create an environment for you. You then activate this virtual environment so that any previous environment that you're currently connected to, you can disconnect from and then activate the new environment that you've just created. Having done that, you install specific packages which are meant to work with this particular version of Python or this particular environment. So if you're working with the machine learning project, you may need specific packages that are not necessary for other projects, and you get them on this particular environment. And then when you want to switch context and work on another project, you deactivate that environment. And once you are done with that particular project, you can also remove that environment, which also removes all the additional packages and dependencies which are related to that package. Hence, virtual environments are a great way to make sure that you can continue working on your various projects without having them conflict with each other. Now, where do I write my Python scripts? Writing any script requires a scripting environment. The list of tools here in this bullet point help you pick the scripting environment best suited for your particular scripting needs. It entirely depends on the task at hand, and I've provided a classification here. So normally for standalone scripts, that is if you're working with one or two Python files, a text editor is great. You could use Terminal, Notepad, Sublime, Idle, or any other text editor of your choice to write Python scripts. In case you're working on larger projects, you could also use your text editors, but some people choose to work with IDEs or integrated development environments. An IDE or integrated development environment basically is a software application that combines tools for writing and testing code. It comes with the functionality that helps you with code syntax, code completion. You can execute the code from within the application without having to exit it and go to another place. Also, the IDE helps you with a result window that provides feedback for the script that you just executed. It comes pre-baked with debugging tools to also evaluate your errors and exceptions. And the third particular scripting environment is Jupyter Notebooks, which is the scripting environment of choice for me. It not only helps you build standalone scripts and projects, it also helps you build tutorials with rich text and images to help the narrative along with your scripts and increase the readability of the tutorial you're working on. Let's take a look at a demo where we'll work with Notepad, that is a text editor, to write a Python script and then we'll execute it. So I have a blank Notepad file here where I'll be writing two simple print statements in Python. So print dev summit 2020 and print the summation of two numbers, which is as easy as print 2 plus 3. Having written these two Python commands, I then save this Notepad file as a Python document, as a Python script. Saving it as a Python script is as easy as adding the .py extension. Once you save this as a .py extension, you are declaring this as a Python script. Having done that, you click save. And there, we see our new script, Python script ready. We now open a command prompt here from the same directory and then execute that script that we just wrote. Executing a Python script is very easy. All you do is Python space and your script name. So in our case, that would be Python space new script.py. This command will execute your Python script. And as we see, it not only printed our first string, it also printed the summation of the two numbers. So writing a Python script and executing it, as we see, is a breeze. Now, coming to the fun parts. Scripting in Python, or any language for that matter, is like working through a recipe. As a recipe has ingredients and instructions, a script also has data and instructions about what to do with that data. We look at scripting in Python through that same lens. We'll first look at the data types that are supported in Python and then the instructions, that is statements and functions, that are supported in Python. This is a list of popular data types as supported in Python. Int means it stores whole numbers, either positive or negative. Float stores decimal numbers, again positive or negative. String stores a sequence of characters that are either within single or double quotes. So you can either store a word or a sequence of words as a string. Boolean is a particular data type that can hold either one of those two values, true or false, that represents the truth or falsehood of the variable. Normally, Boolean variables are used to set or check the status of conditions. We'll take a look at examples. List is an ordered sequence of values with your values stored within square brackets. So as we see in the first example, it could be a list of integers, or as in the second example, your list could have a string, an integer, as well as a float. Normally, lists are mutable, means that the values can be altered. So you can add new values to your list, change existing values, and even delete values from your list. Tuple is similar to a list in the sense that it's an ordered sequence of values, but it has a primary difference in the sense it is immutable. That is, you cannot change values of a tuple. Tuples are stored within round brackets as opposed to square brackets of lists. And again, you can also store values of similar or different data types. The great advantage of tuple is since you cannot change it, you cannot alter it, it's great for working with data that needs to be write protected. If you do not want somebody changing your data, a tuple is a great data type of choice here. And also, since they cannot be changed, they're faster than lists to work through. The last data type we'll be looking at is a dictionary. A dictionary is an unordered collection of key value pairs. So in this example, as we see, name is a key and an is its value, age is a key and 20 is the value. And to navigate a dictionary, you must know the key, and the index needs to be used of the dictionary to reference a particular value and retrieve it. Again, dictionaries are mutable like lists, so you can add key value pairs to a dictionary, change the value for an existing key, or delete an existing key value pair from your dictionary. Moving on to the second part of scripting, that is instructions. Instructions could be statements or functions. Statements are used to perform an action in a script that does not return a value. These are some popular statements in Python. So print, as we saw earlier in that example, can print or return the particular value on the console. Import is used for bringing in packages or libraries into your current scripting environment. Delete or del is used to delete a particular variable. If else are conditional statements. For is a looping statement, and try except is used to handle script errors or to check for expected behavior. Built-in functions now differ from scripts in the sense that they normally return a value, unlike statements. So built-in functions in Python, the popular ones are len, that is, it returns the length of your particular list or tuple. Max and min return the maximum and minimum value respectively. Type is a popular built-in function that can be used to assess the type of a variable. So let's assume you're working with a variable through your script and it has gone through a number of manipulations, and if you want to identify the type it is currently assuming, all you need to do is pass that variable to the inbuilt type function and you'll know. Sum is also a popular built-in function that helps you get a summation of a sequence of numbers. I encourage you click on this link and look at the other built-in functions that are supported in Python to avoid rewriting them. Methods are a specific kind of function that are associated with a specific data type or data object and helps perform a particular sequence of actions, a customized choice of actions on that particular data type or object. We'll see how methods can be written and used. Let's now look at a demo to see how these moving pieces of Python, that is the data types and the functions and statements, come together in order to write scripts. I mentioned we'll be looking at Jupyter notebooks as well. In order to launch a Jupyter notebook, which comes with your Anaconda distribution of Python, you open command prompt in the directory of choice where you'd like to create the Jupyter notebook and execute the simple command Jupyter notebook. What this command does is it launches a Jupyter notebook scripting environment for you in your web browser. And to create a new notebook, all you do is click on new and select Python 3 for the to create a new Python 3 supported notebook. Since I already have an existing notebook, I'll just be launching that from this file structure. So this is how a Python Jupyter notebook looks. And as I said earlier, it allows for rich text, markdown style text in the narrative of your notebook, allowing for distinction between text and code and thus enhancing the readability. We'll first work with integers. So we define two integers here. And then to multiply them, all you need to use is the multiplication operator between them. And there, this has successfully multiplied these two integers. As I mentioned, the built-in function type that can be used to check for the type of an integer. You see the type of this integer is int, that is int. We then define two floating point variables, and subtracting them is as easy as using the subtraction operator. And there, this has successfully subtracted these two numbers. You can also redefine a variable by assigning a different value to it. So changing the value of float to, we now try to add these two to test if it has worked with the new value. And yes, it has used the new value and not the old value of float to. We can also check for the type again, and we see it returns float. A good part of working with numerical data is you can add and work numerically and do numerical computations on float and int at the same time. So you can add a float and an integer together, and you can successfully see it return a result. Strings, as I told you, could be either a word or a sequence of words or characters within single or double quotes. We define our two strings and we print it successfully. Slicing a string is basically just extracting a part of your string by treating it as a list, as an array. So our new slice is 2020, that is, it extracts the year from string 1. This slicing of strings is really important for string manipulation functions. And you can, now that we know 2020 basically is a number and not really a string, you can change the type of the variable new by using the int typecast. And there, we see it has successfully become an integer by verifying the type. Boolean, as I told you, can either store a true or a false value. Let's set the value true to our variable status. This particular code snippet here will give you a good example of how if-else loops work. If status will always default to checking for the value true. So when you're checking for the value of a boolean, it will always assume to check for true. So if status is true, set it to false, else print this message. We then print the message of status outside the if-else loop just to see what the value of status is. Having executed it, we see the value of status is false. Because what it does is, if status is true, which it is, it sets it to false and then prints it. Let's re-execute this code snippet to see what happens. This time it prints nothing has changed, because when it checked for the value of status, it could not find it to be true and so executed the else statement instead, which was to print nothing has changed. And as we see, nothing had changed because it was false previously and continued to be false. Let's move on to looking at lists. Lists, as I told you, is an ordered sequence of values. In this case, it could be, as per the old example as well, a string, a float, or even a number. And accessing a list element is done by the index of that element. So to access the first element, your index past will be 0. To access the second, it will be 1, and so on. And to access all the lists, here we are using the inbuilt function len, which calculates the length of the list, and for each index in that, it's printing the particular element. This is a great example that uses the for loop as well as the inbuilt function len. And there, executing this snippet has actually printed every element from our list. List slicing, as we saw, is similar to slicing a string, which again just gives us a portion, a subset of that list. Deleting an element from the list is as easy as deleting it with the particular index of that element. So as we see, we've successfully removed the year and it has condensed the link to the list to just 3 elements. And adding a new element to the list is as easy as passing that element to your particular list by calling the append method on the list object. And there, we've successfully added 2020 back to our list. Let's now take a look at tuples. Tuples, as I told you, are stored within round brackets and they are immutable. That means you cannot change them. Still, let's try deleting an element of the tuple to see what happens. There, it has given us an error saying that a tuple object does not support item deletion. We knew that already, but this is a great place to introduce the try except statements that I spoke of earlier. What the try except statements do is it helps handle the errors in your scripts or to handle the expected behavior in your scripts. So what we're doing is we're trying to delete this. We know it's going to throw an error, but as opposed to returning an intimidating error to the user, what we're going to do is we're going to handle that error. So if it encounters an error, it's going to execute this except clause instead, where on identifying a type error, it will instead print this message. So it's not going to throw an error to the user, but it's going to handle the error by printing this statement that we've provided for. And there, it did try to delete, but it knew that it had a clause that handles for that error, and instead it gave an elegant message to the user that deleting a tuple element is not supported. How sweet was that? Also, as I mentioned earlier, that a big benefit of tuples is they are write protected, so you cannot have a user change it. A good example is this particular tuple for coordinates. The longitude and latitude for a place does not change, and it's great to store them as tuples instead of lists to avoid for accidental errors of changing them. Again, accessing the elements of a tuple is identical to accessing elements of a list, where all you pass in is the index for the particular tuple element, and that's how we get the latitude. Dictionary, as I told you, is a collection of key value pairs, where in this example, session is the key and Python for geographers is the value, duration in ours is the key, and integer is the value. Thus we see it supports different variable types here. Having defined our dictionary, we then access the value for key session, and we see it has successfully printed Python for geographers. We add a new element to our dictionary by specifying the key and the value for it, which is the speaker and my name. And now we verify, and yes, the dictionary now successfully has another key value pair. Let's take a look at methods. Defining a method or a function is as easy as using the def keyword followed by the method name, and if the method takes any inputs or parameters, which in most cases it does, it's a good practice to add a docstring following your method definition, which specifies to the user in a succinct way what this method is supposed to do and what a user is supposed to expect as a result. So our docstring in this case is it squares a number and returns the square of it. Having defined this method, we now call it. We've defined a list of 3 numbers, and for each number in that list, we are now calling the square method for that number. And there, it has successfully squared the numbers from that list and returned it to us. We'll now look at the import statement that I mentioned previously, which is used to import packages in your current scripting work environment. Pandas is a really important and really popular package for working with tabular data, and it goes by the alias PD. So let's import pandas as PD in our work environment. Having done that, we are now going to access the test CSV within my current working directory. We are going to read that in using the read CSV method within the pandas uh, package, and we are going to store that table in the variable data frame. Having executed it, we'll now call the shape property on the data frame object to get the number of rows and columns. And there, we see that this particular data set has 26 rows and 26 rows and 50 columns. If you want to take a look at this table to see the rows and columns, you can call the head method and pass in the number of rows you'd like to visualize. We've passed in 5, so it returns the first 5 rows for us and all the columns. Here, as we see, this is a crime data set. Also, if you want to visualize 15 instead of 5 rows, you pass in 15 and re-execute this and see it has returned all the first 15 rows for us. Moving on. Here's a list of some really popular open source Python packages. Pandas, as we saw, is great to work with tabular data. It helps not only load tables but also do Excel style data manipulation on your tabular data. NumPy supports mathematical operations on single and multi-dimensional arrays, that is vectors and matrices. Matplotlib and Seaborn are great packages for your data visualization needs. Matplotlib is good for 2D plotting and charting, whereas Seaborn not only supports plotting and charting but is great for making attractive and informative statistical plots. SciPy and scikit-learn focus on the scientific computing. SciPy is built over NumPy with added features. It's used for complex scientific computing in fields of engineering and mathematics. Scikit-learn is built over SciPy with additional features to support machine learning workflows. There are several packages to use for building and scripting your machine learning workflows, but scikit-learn is a great first package to work with and to explore. There are also several other popular packages you must have heard of, such as stat models or bokeh and plotly for visualization, or TensorFlow and PyTorch for deep learning. This again is just the tip of the iceberg. There are several packages to explore, but these are a great first step or a great beginner's guide to get your feet wet with your data science and machine learning workflows. These are a popular list of packages for your GIS workflows. GeoPandas is an extension of pandas to work with geospatial data. So the table we just exported, the test CSV, was actually a spatial data frame. It did have X and Y coordinates for the data, but since we exported it as a pandas table, it would only allow to work with it within the realm of a regular tabular data and with regular tabular data manipulations. In order to work with the added features of spatial analysis, exporting it as a GeoPandas table would be great. Shapely helps create shape geometry objects and manipulate them. Rasterio is great for raster data handling. So you can read your raster images and write them to as NumPy arrays and then plot them using Matplotlib or Plotly. GDAL stands for Geospatial Data Abstraction Library, and it actually encompasses 2 libraries. GDAL is used for manipulating raster data, and OGR is used for manipulating vector data. PyShape reads and writes Esri shapefiles in Python. So all your shapefiles that can be extracted using your favorite ArcGIS products can actually be read seamlessly using PyShape in Python. PySal is great for performing spatial analysis on vector data. Again, there are several other open source GIS Python packages such as GeoPy, Artree, NetworkX, Fiona. Again, this is just the tip of the iceberg and there are a lot more to explore. Let's now take a look at a demonstration for doing a simple GIS and data analysis in Python. For this, let's take a trip through Washington, D.C. This particular example here works with the ArcGIS API for Python. As you see here, the ArcGIS API of Python is the single package that helps us do a bunch of analyses, as we'll see here. Also, it's built over most of the open source packages we just went over. So it really could be thought of as a one-stop shop for most of your GIS and data analysis workflows. We start by importing these packages. We then connect to the WebGIS using this particular GIS object. We then want to extract this particular data set for all the public artwork exhibits in Washington, D.C. We fetch its URL and then search through the web, use the WebGIS using the GIS object for the item that is associated with this URL. Having fetched the item, we then get the feature layer for that item and then convert it to a spatially enabled data frame. Having done this, we then print the shape to see that there are 272 rows or 272 different artwork exhibits in Washington, D.C. and 16 columns or 16 attributes. Let's print the table to have a look at it. So for each artwork here, we see that you have the artist name and the address for where it's located, the art type, also the duration, that is whether it's a temporary exhibit or a permanent one. Let's see this on a map. So we first create a map object using gis.map for Washington, D.C. and set a base map for gray. And then we add the public art feature layer that we previously extracted onto the map. So the map has a base map to which we've added this feature layer, and zooming into Washington, D.C., we can see that this has successfully plotted all the artwork exhibits as points on the map, with also color coded based on the duration, that is if they're temporary or permanent. As I mentioned previously, Jupyter notebooks are great to add images as well. So I'd already added an image for the output for this analysis. Now we'll create a bar chart for the art type. So we first execute the value counts method on the particular art type column of the data set. Having done that, we then import the particular visualization packages we spoke of earlier, which is Matplotlib and Seaborn. Having done that, we set the preferences and execute the script that actually generates our bar chart. And as we see, most of the art exhibits are murals, then followed by sculptures. Let's now create a pie chart for the duration of these exhibits. So as we know, the duration could either be temporary or permanent. And then this script right here creates a particular pie chart. And as we see, 56.2% of our exhibits are temporary, while 43.38% are permanent, telling us that most of them are temporary or short-lived, and it's time we actually know which ones to go and visit. So to do that, we'll now fetch the administrative boundaries or wards for Washington, D.C. Similar to the art exhibits, we first fetch the URL and then search the WebGIS for the particular URL. Having searched it for that particular URL, we then fetch the feature layer that is associated with it. Having done that, we now add this feature layer to our existing map of the base map and the art exhibits. If you notice here, I haven't converted this particular item or this feature layer to a spatially enabled data frame. The reason being, we're not using this for analysis purposes. We're just using it for visualization on the map. Having done that, we can see that it successfully adds this to the map in the form of boundaries so that you know clearly which exhibits you'd like to target first and visit and which you'd like to leave for later based on the duration. Having done this, we now take a look at the learning resources. W3 Schools has a great resource that gives you an interactive learning environment where you not only have the explanation for the various syntaxes, but also you have prompts to write in your Python code and practice them on the fly. This URL right here is great to explore the Python official docs to understand the language in depth. These books by the O'Reilly publication are great to understand Python in an intuitive and easy to understand manner. While the previous example focused on the ArcGIS API for Python for WebGIS, for your desktop GIS needs, you'll need to work with ArcPy, and I strongly recommend you explore esri.com/training for our extensive suite of fantastic training resources to understand ArcPy and several other means of working with Python. We also have books released by Esri Press to understand Python scripting, be it for ArcPy or Python API. This resource right here, that is developers.arcgis.com/python, is great to understand the Python API. What I showed you now in the demo just basically scratches the surface, but this URL right here is great to understand how to install it, and then also shows you various other methods and examples and workflows that can be achieved using this API. And if you've already dabbled with Python a little but would like exercises to flex those muscles and to practice on puzzles, I recommend you take a look at practicepython.org. They have a bunch of use cases and puzzles that can be solved for you to get comfortable with the syntax and scripting of Python. To recap, we first saw how to fetch Python and install it on your machine with the Anaconda distribution, which is suited for data science and machine learning workflows. We then saw what kind of script you need to write, that is a standalone or a project, or be it building a library and then, or a tutorial, and then choose the environment that's associated or best suited for it. We then saw the secret sauce for scripts, that is, a script is nothing but a recipe. How a recipe has ingredients and instructions, a script also has data and data types for it and instructions. We then saw a bunch of open source libraries that are great to get started with in order to work with data science, machine learning, and your GIS analysis. We saw the ArcGIS Python API to work with WebGIS or your data on the web, but I'd also suggest you look at ArcPy in case you've got your data on the desktop GIS, that is ArcMap or ArcGIS Pro. The slides and demo for this particular presentation are on this URL. And to conclude, Python is a lot of fun, and clearly it's going to be fun to explore it and learn more and build fun things with Python. I'd love to learn what you build with Python and what you learned from this particular session. I hope this was useful to you, and thank you for attending this session. Let's hope to connect on GeoNet, and thank you.